Distinguished speakers, distinguished guests, I'm very pleased to welcome you to today's webinar, which is a part of a series of webinars where we are discussing important topics related to nuclear arms control, disarmament, and arms control. My name is Benedikt Zanzinger. The Multilateral Dialogue of the Konrad-Adenauer-Foundation, together with Atomic Reporters, is pleased to present this online discussion on IAEA safeguards and naval nuclear propulsion. Today's discussion will examine the various facets and implications of the challenge posed by naval nuclear propulsion to the IAEA safeguard system, the resulting effects of the agency's ability to verify nuclear activities in non-nuclear weapon states and implications for safeguard conclusions, as well as the challenges of naval nuclear propulsion for newcomer states. These and related issues will be examined today by experts in the field. A previous discussion on nuclear submarines, who will get them next, was held on the 21st of November in 2021. Please visit the website of the Konrad-Adenauer-Foundation and Atomic Reporters and our YouTube channel to watch this video from last November. Please let me introduce the moderator of today's discussion, Tarek Rauf. Good evening. Tarek is a member of the Board of Directors of Atomic Reporters and Canadian Pugwash. He's a former head of verification and security policy at the IAEA. He was a member of the Eminent Persons Group for Substantive Progress on Nuclear Disarmament, convened by the Foreign Ministry of Japan. Actually, his first publication on today's subject was in 1988, entitled Opening Pandora's Box, Nuclear-Powered Submarines and the Spread of Nuclear Weapons. There's a more recent publication on IAEA safeguards, the continuing challenge of nuclear submarines. You will find this information and further publication reference on the other speakers, on the invitation letter and our homepage. Please allow me one technical remark. This webinar will be recorded and uploaded on our website and our YouTube channel. Please keep your audio and video sources muted. And please submit all your questions and comments through the question and answer function. The moderator will then select or summarize questions to the speakers and will try to accommodate all questions, time permitting. Without further ado, I will now pass the floor to Tariq, who will be moderating this webinar. Tariq, the floor is yours.
Thank you very much, Benedikt. And I too would like to join Benedikt in welcoming all our participants and in particular our three speakers today. As Benedikt pointed out, we first discussed this issue a year ago, following the announcement of an agreement between Australia, the United Kingdom, and the United States on providing Australia with a fleet of nuclear-powered but conventionally armed submarines. In June of this year, Brazil also informed the IAEA that it was developing an indigenously developed nuclear-powered submarine. Now, under the Nuclear Non-Proliferation Treaty, all non-nuclear weapon states, such as Australia, Brazil, and others, are obligated to declare and place all nuclear material and all nuclear activities under IAEA monitoring and verification, known as safeguards. However, the safeguards agreement, which was negotiated in 1970-71, includes a paragraph whereby such non-nuclear weapon states can ask the IAEA for the non-application of safeguards on non-peaceful or non-proscribed military activities. And naval nuclear propulsion, as well as space propulsion, are two such non-peaceful, non-proscribed military activities. So the question for the IAEA's verification system and for the Non-Proliferation Treaty regime is that countries that do operate nuclear-powered submarines, if they are exempting the nuclear reactors and the nuclear fuel from safeguards, does this create a gap in the agency's knowledge on the nuclear activities of the state concerned? And what sort of safeguards conclusion would the IAEA be able to provide to such states? The normal conclusion is that all declared nuclear material remained in peaceful activities, and that a broader conclusion is that the IAEA found no indication of undeclared nuclear material and activities, and therefore all nuclear material and activities in such non-nuclear weapon states remained in peaceful use. So these are some vexing questions. In addition, there are no agreed definitions on non-proscribed or non-peaceful military activities. Also, there are no studies in the public domain on the reactor physics as regards the irradiation of nuclear fuel in nuclear-powered submarines, and whether there might be any proliferation concerns, whether at the end of life of the core or at other times. And also, both Brazil and Australia will be newcomer states to naval nuclear propulsion, while both of them do have experience operating diesel-electric submarines, but operating nuclear submarines poses very different operational challenges in terms of safety, risks, and so on. So we will address all of these three issues today. Our first speaker will be Dr. Sophie Groppe. She is joining us from Uppsala, Sweden. She is senior lecturer, associate professor at the Department of Physics and Astronomy, specializing in applied nuclear physics. We hope then to get Mr. Unit Susanu, head of the Non-Proliferation and Policymaking section in the Office of Legal Affairs at the International Atomic Energy Agency, followed by Rear Admiral John Gower, who is director of Mimir Consulting, and he served until his retirement in December 2014 as the Assistant Chief of Defense Staff in the United Kingdom's Ministry of Defense. And for half of his 36-year military career, he was at sea commanding 2 globally deployed submarines. I believe one was conventionally powered and one was nuclear. So with this introduction, may I now invite Dr. Sophie Groppe for her presentation.
Thank you very much, Tariq. Let me start with sharing my screen. Can you all hear me good? Maybe, yes, I hope so. I cannot see you now anymore, but I can see my presentation. I hope you can do the same. Otherwise, please speak up. So as Tariq kindly told you, I am working at Uppsala University, and the work that I will present to you here today was also done within the recently established Alva Myrdal Center for Nuclear Disarmament at Uppsala University. So it's a collegial effort with colleagues mentioned on this slide. So the background for this study is, of course, the AUKUS Trilateral Security Pact. Here we have a pact between 3 different states, 3 NPT signatories, where 2 of them are nuclear weapon states and 1 is a non-nuclear weapon state. As you all are fully aware, it was announced recently that this pact would cooperate on a number of topics, where one topic to be investigated is the use of nuclear-powered submarines by Australia. Possibly these reactors would be placed inside the American Virginia-class submarine. And as Tariq already explained, this is not something that is prohibited in the NPT, but it is possible for a non-nuclear weapon state to use nuclear material for naval propulsion purposes outside of safeguards. There are some identified non-proliferation challenges associated with this, where I would say the main concern is that the AUKUS deal would set a precedent for future proliferators to use a naval reactor program to cover up as a cover to develop nuclear explosive devices. Others before us have looked closer at these different challenges. Jan Carlson identified a number of diversion scenarios associated with naval fuel programs, where you can see 5 listed options here. where it's a diversion of the low enriched uranium or high enriched uranium from an enrichment facility. It could concern diversion of stockpiled LEU intended for fuel fabrication, or diversion of nuclear fuel material from a fuel fabrication plant, establishment of undeclared enrichment plants, or diversion of LEU and HEU spent fuel from storage, followed by reprocessing. So our work was done in the context of the last bullet here, where we did not consider the HEU stored in a storage, but actually the HEU core inside a Virginia-like submarine. And we also only considered the operation of the submarine. We did not consider the enrichment facility, fuel fabrication plant, or any reprocessing. So our work is technical, and it's meant to complement any ongoing discussions that concern the non-proliferation implications of the AUKUS deal. And how we wish to contribute is to assist with identification of attractiveness of the highly enriched uranium fuel material inside the submarine reactor, and to evaluate whether or not it's suitable to use in a nuclear explosive device. We've also tried to look somewhat at how this attractiveness varies over the lifetime of the core to draw conclusions on whether or not it becomes more or less attractive during irradiation. Everything that we have done is done using openly available material. And the end goal is then to assess how the isotopic composition of the HEU changes over time. This builds on a number of different tasks, where the first one is to collect information on the reactor core design. That's not totally obvious how you get such information, which is often classified, but there are indeed some sources that are published and available. So with that information, we implemented a suitable model of the submarine reactor fuel and then simulated its operation. We also extracted results on the evolution of the isotopic composition. That means on the material properties of the reactor core. And in the end, we made an evaluation of how useful the material would be for non-peaceful applications. So the implementation that we did actually consisted of various submarine reactor cores. We did actually 4 different designs. And we used a Monte Carlo simulation code called Serpent, and only openly available information. We also limited ourselves to a very small part of the reactor core, so we did not simulate its full core or any structure material around it. We simply made what we call a unit cell that comprised the HEU fuel plates, the cladding around the fuel, absorber plates, and also water as a moderator or cooling material. You can see an example of the fuel here in the image to the left. It's not from a submarine, but it's meant to show just briefly an overview picture. Then you can see the model that we implemented in the Monte Carlo code on the right. The operation of the submarine reactor, we modeled under various conditions. So we assumed varying operation of the reactor, either operation at 25% of full power during 6 months per year, which is, I would say, the more realistic scenario. But we also looked at various simplified operations corresponding to a certain number of full power days instead. We also varied the power level and the temperatures of the fuel and the water. Then we did the analysis of the isotopic composition, i.e. the material in the core. And of particular interest is, of course, any material that can be used in a nuclear explosive device, meaning uranium, plutonium, and in this case also neptunium. So not very unexpectedly, we could, of course, find that as the submarine reactor is operated, the content of uranium-235 decreases, as you can see in this plot. In the beginning, the HEU has an enrichment level of 93 to 97.3%, depending on which design we implemented. And that corresponds to about 25 significant quantities per reactor. During irradiation, you consume the uranium-235, and in the end of life, the reactor still has quite a significant fraction of HEU remaining. The enrichment is on the level of 60 to 73% in our result, and this is an enrichment level which is far above the 20% limit, but also lower than the weapon grade limit at 90%. The end-of-life core uranium could be useful in some nuclear explosive devices, but it's clear that the fresh fuel is of greater use in a nuclear explosive device. When it comes to the plutonium, we did the assessments in light of nuclear safeguards, which includes plutonium with a content of plutonium-238 less than 80%, and where plutonium with lower levels of plutonium-240 and 7% is defined as weapon grade. For a Virginia type reactor, the total amount of plutonium is rather low. It's about 7 kilos per submarine reactor. If we look at the isotopic composition of the plutonium, you can see that it has quite a large fraction of plutonium-238, although it's not as high enough to exclude it from safeguards, meaning that if the material would be reinserted under safeguards, it would be of safeguard concern. You can also see that the plutonium-240 is around 7%, which is the limit for weapon grade, and also that there is a considerable amount of plutonium-239. What you can see in the image on the right is that plutonium-238, which is the green dotted line, it starts to increase after operation 15 years, meaning that the plutonium is a better weapons quality at shorter irradiation time, meaning that it becomes less and less attractive the higher the burnup becomes. About the plutonium-238, we found that it's actually so much that it cannot be excluded from the analysis or from conclusions drawn on this, despite that not all previous authors of submarine reactor studies have taken it into consideration. Depending on your frame of reference, you can either note that, okay, all plutonium under safeguards can be used to manufacture nuclear explosive devices, meaning that this surely is very relevant to safeguards. There are also others that say that this plutonium is of little use in a nuclear explosive device, mainly because of the very high content of plutonium-238, which generates a lot of heat. Actually, there is so much plutonium-238 in this fuel that it could motivate the use of the fuel in, for instance, heat source applications such as space missions. You could also see from the results that the fractions of plutonium-240 are low enough to serve in the safeguards community, the weapon grade classification, but that does not mean that it's weapons usable or weapons suitable. The classification of weapons grade originates from the experience of reactor fuel, where plutonium-240 was a good indicator of weapons usability. And that translates to light water or heavy water graphite reactors, but not really the type of reactors that we are looking at here. Interestingly enough, we could also find that you produce a lot of neptunium in this type of core. This has not really been assessed in earlier works that we looked at. And in principle, the neptunium could also be used to create a nuclear explosive device. And more importantly, it's not the material that is under safeguards today. In total amounts, the production of neptunium in a Virginia core is very similar to plutonium, just slightly lower. And this could actually be a non-proliferation concern if the spent fuel is ever reprocessed. Also on this slide, you can see that the conclusions or the results that are presented here, they are actually not so much dependent on the assumptions that were made in the beginning. The irradiation time in the reactor or how you operate the submarine doesn't really change much when it comes to the material composition or properties. The most important factors for determining the production of neptunium or plutonium is linked to the initial fissile material in the core, the discharge burnup, which means how long you operate the submarine, and the amount of neutron absorbent material you have in the core. To conclude, material-wise, we can see that the uranium, the HEU, is actually most attractive for use in nuclear weapons applications before it is irradiated, meaning that it's really important to ensure that the fresh fuel does not become diverted. The fully irradiated material could be of interest in some nuclear weapons design, but reprocessing of the core is then needed, and possibly one would then also assume re-enrichment up to levels of above 90%. The plutonium at the end of life in the reactor is of poor weapons quality. The fresh fuel, on the other hand, contains no plutonium at all, meaning that plutonium builds up during operation, and it's of better weapons quality, so to say, the lower the irradiation is. However, then you don't have much material either. So there is a trade-off. The isotopic composition of the fully irradiated fuel at the end of life, it's undesirable in a nuclear explosive device. However, the large plutonium-238 content could motivate an interest in reprocessing the spent material, which would be a large non-proliferation concern, I would say. That would also be the same if you consider the enrichment of the fresh fuel to be used in the submarine. We also concluded that the definition of weapons grade is plutonium is insensitive to the amount of plutonium-238 in the material, meaning that it's not really a good indicator of weapons usability. We also noted that the 8 submarines in the OPUS can jointly produce an amount of neptunium-237, which is corresponding to a critical mass, which means that it could theoretically be used in a nuclear explosive device, but it would also require reprocessing. However, neptunium is not really safeguarded, and it's thus not really included in the non-proliferation and safeguards regime in the same manner as uranium and plutonium, which maybe one needs to do. So by that, I thank you for letting me present this work.
Thank you very much, Sophie. That was a very informative and interesting presentation. You referred to SQs, or significant quantities. So for IAEA verification purposes, a significant quantity of highly enriched uranium is 25 kilograms. But in practice, the IAEA endeavors to track all nuclear material. So you mentioned the Monte Carlo Code. Could you explain to a Vienna and Geneva audience what is the Monte Carlo Code and what are the benefits for using this methodology?
Yes, sorry. Monte Carlo codes are often used to simulate how a reactor and the fuel in a reactor behaves during irradiation. It's a way to assess material buildup and then material production, and also properties of the material, such as, for instance, the radiation that it emits and overall the properties that it has. So it's a very good way to learn about the, in this case, development of a material during irradiation, or during also decay, maybe after you have discharged material from a reactor. What happens to it, and how do you able to assess properties of it?
Thank you. So you mentioned that the fresh fuel would be more attractive from a diversion perspective at one level. Yeah. Now, fortunately, in previous discussions, it has been decided that enrichment for a naval nuclear program is classified as peaceful and therefore would remain under safeguards. Yes. But there is still the possibility that once the fuel leaves the enrichment facility and it goes across the line where the state says now it is in military use, and the state defines what is the dividing line, unfortunately. And under the exemption in the safeguards agreement, it is not up to the agency as far as we understand, but for the state. And that no military or classified information should be shared with the IAEA. So what sort of measures might you suggest that the IAEA could look at, that this transition from the peaceful to the military side is done in a way that the diversion scenarios could be minimized, if not prevented?
I think it's a very important point that you bring up, and I think it is important that the agency tries to monitor this material as long as it is possible to do that, actually. As I explained to you in this presentation, the material that you put into a Virginia-class submarine is very similar to the uranium you would actually use in a nuclear weapons design. So it's that's really the most attractive material to use. So I would assume that you would have to monitor it closely during transport, and also perhaps put the seal on it until it's no longer possible to have the seal on it. But it would be, in my opinion, the most easy way to gain access to a material without having the burden of needing to possibly avoid high radiation doses when handling the material, or needing to reprocess to separate various material streams.
Okay, thank you. You also mentioned that there would be neptunium in the core. And as you correctly mentioned, neptunium is not under safeguards. Both americium and neptunium are reportable. Several years ago, the IAEA started writing letters to states to inform them about quantities of americium and neptunium in their possession, but very few countries actually report under the voluntary reporting scheme. So most people have heard about uranium and plutonium being used to make a bomb. How much neptunium would be needed to make a nuclear explosive device? And is it more radioactively or radiologically hazardous than using highly enriched uranium or plutonium?
No, it's actually rather attractive, I would say. The main threshold so far has been that it's difficult to separate the neptunium because it's together with other elements and isotopes. But that's also why we identified in this work that if one would actually see plutonium-238 as a source material for heat applications, then actually that could motivate that neptunium is separated and then becomes available. So it would be on the same level as uranium and plutonium actually for deployment in nuclear explosive devices.
Thank you. So my last question for this round is, I think it would be very useful if the IAEA Safeguards Department were to contact you and cooperate with you in doing some of this research. So do you think that would be useful?
Yes, it would be very useful. Within the Alva Myrdal Center, we are actually looking at the availability of neptunium as well, and assessing its usability in nuclear explosive device settings. So we would very much encourage that. Okay,
thank you very much, Dr. Sophie Groppe. So let's now move on to Mr. Unit Susunu, whom I already introduced as the senior lawyer for Safeguards. He's the head of the section for non-proliferation policymaking in the Office of Legal Affairs at the International Atomic Energy Agency. So over to you, Unit.
Okay, thank you, Tariq. Good evening to everyone. And of course, my background is not technical, so my presentation will not address technical elements as Sophie did. So I want to start with with a general description of the CSA. Of course, the non-nuclear weapon states have the obligation to conclude with the IAEA safeguards agreements pursuant to Article 3 of the NPT, under which safeguards have to be applied on all source and special fissionable material in all peaceful nuclear activities in the territory of the state under its jurisdiction or control anywhere. As you know, nuclear material is not defined in the NPT, but in the safeguards agreement, nuclear material is as defined in Article 20 of the statute, and that refers to special fissionable material and source material. That is uranium, plutonium, and thorium. Americium, neptunium are not nuclear materials subject to safeguards under an NPT safeguards agreement. So peaceful nuclear activities are not defined. Non-proscribed military activities, as Tariq mentioned earlier, are also not defined. However, in the context of the negotiations that took place in the Committee 22, which elaborated the document 153 on the basis of which the states are concluded comprehensive safeguards agreement, many delegations, when elaborated paragraph 14, had in mind that one of a possible non-proscribed military activity would be the use of nuclear material for nuclear naval propulsion, including submarines. So that is part of the legal framework. All safeguards agreements that have been concluded by non-nuclear weapon states parties to the NPT are based on this document. The IAEA has the right and obligation under the CSA to verify the state undertaking not to use nuclear material subject to safeguards for the manufacturing of nuclear weapons or other nuclear explosive devices. So the non-proscribed military purpose, as used in paragraph 14 of this document, means other than explosive or the manufacturing of nuclear weapons. Of course, it's for a state to decide whether it wants to make use of the provisions set out in this paragraph. So it's the state discretion and right. In case it wishes to use nuclear material subject to safeguards for submarines or nuclear propulsion, first to inform the agency. Then there are a number of steps that the state and the agency have to follow. First, the state should practically reaffirm the commitment under the NPT not to use nuclear material for non-proscribed military activities for the manufacturing of nuclear weapons and other nuclear explosive devices. The state cannot use material which was subject to a previous safeguards agreement, item specific, or a project and supply agreement for such activities. So, as you know, many states concluded prior to the NPT entering into force, and they concluded CSAs, item-specific safeguards agreement. The undertaking under those agreements is not to use nuclear material and other items which are subject to safeguards for pursuing any military purpose. That would be the second step. The third step is for the state and the agency to make an arrangement so that only while the material is in a non-proscribed nuclear material activities, the safeguards provided for under the CSA will not apply. So this arrangement is temporary in nature. So it will apply only while the material is used for naval nuclear propulsion. The material can be produced domestically or can be imported from another state. If the material is domestically produced or is imported from another state, the state has to inform the agency accordingly. And the safeguards procedures provided for in the agreement would apply before the nuclear material is used for nuclear propulsion, as well as after such use. The agency has experience in applying safeguards to different types of reactors, power reactors and research reactors that used nuclear material ranging from natural uranium, low enriched uranium, high enriched uranium. So in discussing arrangements with states pursuant to paragraph 14, the IAEA will not start from zero because has a long experience in applying safeguards to research reactors using inter alia high enriched uranium. What the arrangements should include, they should include inter alia information about the quantity of the nuclear material, so is the mass of the uranium, if uranium will be used for propulsion, and the composition, so whether it's low enriched uranium or high enriched uranium. Reporting provisions. Of course, this is subject to consultations. The state has to inform the agency whether the material is produced domestically, what are the stages in which the material will be produced, or if the material will be imported, when the importing state will take the responsibility on the nuclear material before it arrives in the country or when it arrives in the countries. So based on this technical information, the agency, in consultation with the state, will develop the necessary arrangements as envisaged in paragraph 14. In making such arrangements, yes, we don't have the right to approve classified information, classified military information. Of course, the information is not owned by the agency. So the state also has to tell the agency what kind and what type of information the state considers to be sensitive and would need to be protected accordingly. So to sum up, all these arrangements, yes, would apply only while the material will be used in such non-proscribed military activity. Prior to its use in such activities and after it has been used, the agency has to apply all the safeguards procedures that are provided for in the agreement. I want to add one more element. So this is not the only part that is relevant for such use. So the definitions, in particular, the definition of inventory change, yes, contains additional information regarding reporting of material that is used for non-proscribed military activities and the reintroduction of such material after use in activities that will be under safeguards. So the material is in the inventory. It is removed from the inventory when it is used for submarines, and it's again added to the inventory. As you know, we have no implementation practice with respect to the application of paragraph 14. We have provisions in the agreement, in particular in paragraph 3, that requires the cooperation of the state to facilitate the implementation of safeguards, including this paragraph. But also you have another provision in Article 20 that provides for a consultation process between the state and the agency with respect to the interpretation and the application of the safeguards agreement. Now, with respect to the two states that are working on a projects involving naval nuclear propulsion, we are at an early stage. So we started the consultations and will continue such consultations. The Director General has kept the Board of Governors and Member States informed on the developments on these two projects.
So are you done, Unit?
Yes.
Okay, thank you very much for providing us that description. There are many questions, but we don't have time to go through all of them. So I have a few for you. Just to clarify, when you were describing the provisions of paragraph 14 of INFCIRC 153, the Comprehensive Safeguards Agreement, I think you mentioned that material that is required to be safeguarded or under safeguards already cannot be used for a non-proscribed military purpose. Is that correct?
To clarify, nuclear material which was subject to safeguards pursuant to an item-specific safeguards agreement or an agency project and supply agreement, yes, cannot be used for activities envisaged in paragraph 14. Why? So, because the undertaking under an item-specific safeguards agreement and the project and supply agreement is not to use the items subject to safeguards to pursue any military activity.
Yeah. So that means that a country invoking paragraph 14 could have material which is under safeguards and ask the agency for non-application of safeguards on that material for non-proscribed use.
Yes, of course, we have to look to the other safeguards agreement that the state had concluded with the agency. As you know, for item-specific safeguards agreements, yes, they are not terminated when the CSA enters into force. We suspend the application of safeguards under those agreements, and we apply safeguards to all nuclear material under the CSA.
So you described paragraph 14 for 153, which is more applicable in some sense to Australia. But as you know, under the Argentine-Brazilian bilateral agreement, naval nuclear propulsion is described as quote unquote a peaceful activity. And under the quadripartite agreement, which is between Argentina, Brazil, the Agency for Accounting of Nuclear Material between Brazil and Argentina, and the IAEA, it is paragraph 13, which calls for special procedures. So what is the current view of the agency of what might be these special procedures?
So as I mentioned, we just started the consultation process.
Okay.
So the wording is different, yes, because the quadripartite safeguards agreement, yes, was concluded in connection with the bilateral agreement between Argentina and Brazil that provided for the application of safeguards to all nuclear activities. Yes, the word peaceful is not used in that bilateral agreement. Yes. Again, the Board of Governors approved an exchange of letters, yes, between the agency and each country, Argentina and Brazil, confirming that the agreement also satisfies the provisions of Article 13 of the Treaty of Tlatelolco, which also requires the application of safeguards to all nuclear activities. Again, this article doesn't use the word peaceful, yes? And in another exchange of letters approved by the board after the two countries joined the NPT, also confirmed that the quadripartite agreement also satisfies the requirements set out in Article 3 of the NPT for each of the countries. Yes, so this is a historical reason for why the wording of paragraph 13 of the quadripartite agreement is not identical with the paragraph 14 of 153. So this is not the only CSA that provides a description what would be a non-proscribed activity. Yes, could be propulsion, could be prototypes, yes, or any other activity as agreed between the agency and the state concerned. Yes, there are a few other CSAs that use the same language.
So under Article 3 of the Argentine-Brazilian agreement, which is INFCIRC 395, I quote, "None of the provisions of the present agreement shall limit the right of the parties to use nuclear energy for the propulsion of any type of vehicle, including submarines, since propulsion is a peaceful application of nuclear energy."
Correct. So
what do we mean by that?
When we talk about propulsion, yes, we are talking about the reactor, and we are talking about nuclear material contained in the reactor that will facilitate the propulsion of the vehicle. Yes, so of course we cannot apply safeguards, yes, under a CSA to an activity. We apply safeguards to nuclear material that could be in a facility or in a location outside facilities, right? The facilities as described, as defined in the CSA, include critical assembly, a reactor of any type, conversion facility, fuel fabrication plant, isotope separation plant, reprocessing plant, or a separate storage installation. Yes, the focus of safeguards is on nuclear material because this is the main ingredient from which a nuclear explosive device or a nuclear weapon may be produced. Yes, so through the implementation of safeguards, we follow the flow and verify the inventory of nuclear material. Yes, and we keep track of the inventories, of the consumption of the material, when the material is changing its physical or chemical properties or the form. Yes, so all these changes need to be declared by the state, and the agency has the right and obligation to verify to ensure that the material stays in peaceful nuclear activities, of course, with the exception of cases when arrangements will be made in order for such material subject to safeguards to be used for naval nuclear propulsion.
Okay, thank you. So I have two final questions before we move to Admiral Gower. So, if propulsion under this Article 3 is a peaceful application, then can we not say that just as enrichment for this purpose has to be under safeguards, the reactor itself has no military use. It's just an engine providing electricity to run the submarine. So therefore, should not the reactor also be under safeguards? What the submarine does in operations is military activity. The reactor is only using material to generate electricity. So why not include that under safeguards as well?
So if we read carefully, paragraph 14, it only refers to nuclear material, correct? It does not?
No, I'm referring now to Article 3 of the Argentine-Brazil Agreement, INFCIRC 395, which agency has the obligation and right to implement. And
Yes,
Brazil will likely use that. And that's what they said in their NPT statement in August.
Yes, so when a country is building a new facility, yes, we always ask the country to provide early design information. Yes. So when a decision was taken by the state to construct or to authorize construction of a facility, the state has to provide early design information, even if the state did not start the physical construction of a facility. Yes. So this is clear. However, if a facility will be considered to be sensitive because of its future use, the state has the right under Article 8 of the CSA, yes, to request the agency to examine such design information on the premises of the state, yes, if that information is of particular sensitivity. And such design information shall not be transmitted physically to the agency, providing that it remains available for examination on the premises of the state. Yes, this is the general framework. But of course, when we discuss about the arrangements, we discuss about specifics. Yes, so the information is owned by the state. Yes, so the state has to tell the agency which characteristics or elements of the design information is considered to be sensitive because of its future use for naval propulsion.
Okay, thank you. So last question, how will this affect the safeguards conclusions for a state implementing non-application of safeguards? The CSA conclusion, and if a state has an AP, the broader conclusion.
So I think it's too early to speculate on how that may affect the safeguards conclusion that the agency would draw for a state that made arrangements with the agency in the context of Article 14 of the CSA, or in case of Brazil, Article 13, because we are at a very, very early stage. Of course, the conclusion is based on the findings. Yes. So even if we are making arrangements, yes, in accordance with the safeguards approach, SLA, yes. So we have to pursue all three generic objectives for all states with the CSA to identify if there is any diversion of declared nuclear material from declared activities, to identify if there is any undeclared processing or use of nuclear material, not only declared, but nuclear material subject to safeguards, at declared facilities and lofts. And the third one is to seek if there is any undeclared nuclear material and activity in the state as a whole. So to attain these generic objectives, the agency has to develop an acquisition path analysis to identify on that basis technical objectives which are state specific, because that depends on the nuclear fuel cycle of the state, the nuclear program, the declared facilities and lofts, the technical capabilities of the state with respect to nuclear fuel cycle activities, and further to identify the safeguards measures that could be implemented in order to achieve the technical objectives. Yes. So the technical objectives will pertain to each of the three generic objectives. If a state has an additional protocol, of course, we have more tools available in order to to attain those objectives. Then all the measures to be implemented, yes, are included in an annual implementation plan, which is normally approved by the head of the Department of Safeguards and is implemented during the year. At the end, we evaluate all safeguards available information. That means information provided by the state, information resulting from our in-field verification activities, and also information resulting from analysis of other sources, including open source information. On that basis, yeah, we draw the safeguards conclusion. So even if a state had a safeguards conclusion, which was non-diversion of declared or all nuclear material remaining peaceful activities, this is not carved in stone. Yes, so that may change on the basis of the agency's findings. But of course, whenever the agency identifies anomalies, discrepancies, yes, it's following up with the state, you know, to in order to take corrective measures. So even if such arrangements will be made, so the agency will continue to implement safeguards and identify if there is any undeclared nuclear material and activities where the material that will be subject to this paragraph could be used. Yes. So of course, if there are no indications of reprocessing facilities, yes, so there is a lower risk that material that was subject to paragraph 14 would be reprocessed in the country.
Okay, thank you very much, Unit, for giving us all the detailed answers. And now we move to a different facet of our discussion as regards the challenges of operating submarines, in particular nuclear-powered submarines. And for that, we have Rear Admiral John Gower, whom I already introduced to you, who spent more than half of his long career at sea commanding 2 globally deployed submarines. John, over to you.
Thank you, Tariq, and thank you to the previous presenters. You say that you always learn from Zoom, and I have learnt today that Brazil is taking a very different approach to its relations with the IAEA than Australia and the AUKUS partners are. And I think the Brazilian approach, by the sound of it, although I'm no expert, will provide them with more complications in deriving a satisfactory certificate of safeguarding, if you'll allow me my shorthand as a naval officer rather than an IAEA lawyer. I wish them well on that. I wanted to talk, I mean, I can answer any sorts of questions on how hard it is to operate submarines, but I wanted from my perspective to talk, and I must emphasize that whilst I was working for many years for the United Kingdom government through the Royal Navy, I no longer do so. And so any remarks that I make are entirely my own, but they are informed by my time, 36 years in the Navy. I wanted to talk about AUKUS in the light of the discussions that have been made by the other 2 presenters, because what is being represented as the threat to the non-proliferation regime is not the intent, as I understand it, of the AUKUS partners. And they have been very open with the IAEA and produced in July of this year a paper to the review conference, but also as part of the ongoing discussions with the IAEA and its Director General, and specifically laying out the manner in which Australia, as a state currently without any nuclear capability whatsoever, it has no civil nuclear generation program, and therefore sits, if you like, in a virgin state in terms of its safeguards. But it does hold, as has been stated, a comprehensive safeguards agreement and an additional protocol relating to its activities. And it's intended that the manner in which the fissile material contained in the reactors of the submarines is handled will be completely in accordance with both of those. And indeed, I think far from being the gateway to proliferation, I think the AUKUS program could provide a model of safeguards for other naval nuclear propulsion programs if they do continue. And we discussed, Tariq, that the merchant marine community is seriously looking at nuclear reactors as a means to both decarbonize, but also make safer and cheaper to run the merchant traffic upon which our economies and livelihoods depend. And I think that in itself, with the multitude of flagging and ownership of merchant ships, provides as big, if not a bigger challenge to safeguarding in the future than this does. And it may be that the AUKUS deal provides mechanisms that will assist that downstream. Australia has made it clear that it will not pursue enrichment or reprocessing, so it won't be involved in the manufacture or the disassembly of the reactor plants under its control. It will be provided either by the UK or the US or a consortium of the two with essentially plug and play reactor units. And many people that I've spoken to, and certainly myself, consider the safest place for enriched uranium is inside the fuel cells of a welded naval reactor inside a naval nuclear submarine that is subject to the security controls of that submarine. I think if you were looking to illegally acquire highly enriched uranium, that's probably the most challenging place from which to get it. So these submarines would arrive in Australia and would be removed from Australia at the end of their reactor lives. So there will be no need for any facilities to manufacture or process. And I think that there is just one issue with that, with the management of the submarine, is that during its life, a nuclear submarine requires maintenance. It requires activities going on in the reactor compartment. Some of those may involve ancillary machinery. I assume that the reactor type will be one that does not require refueling, but I think there are some challenges to be undertaken by the AUKUS team as to how that will be managed in a country that has no indigenous nuclear power generation expertise. But I'm sure that will be managed within the constraints of the contract under which Australia buys and operates these submarines. In many ways, from a reactor component, the reactor section of the vessel, in many ways, they are leasing it rather than buying it. And I think the deal will end up, and I have no inside track on this, but it will end up with a provide, maintain, remove cycle with one of the UK or the US or both operating that. I know there is a lot of interest in whether IAEA would gain a specific access to the reactor itself, either before it is on the vessel, once it is manufactured, or once it has passed through the safeguards barrier between where the uranium came from and where it's going, and before it passes out of that barrier again as fuel to be reprocessed. That barrier being the non-proscribed military activities, including naval nuclear propulsion. I think that's both a wild goose chase and extremely unlikely to happen. I do think that if Brazil goes down, or I speculate that if Brazil goes down, that these are peaceful units and they're not seeking to operate them under the protection, in inverted commas, of non-proscribed military activity, that it might be more difficult to fend off the concepts of tagging and inspection. But that's a matter for Brazil and potentially France as their advisors to discuss. But I think in terms of any thought of IAEA inspectors as part of whatever protocol AUKUS deals up, getting access to reactors, affixing seals, checking seals, radiation monitoring, that's a non-starter. Because as as I had said, that the legalities, or not the legalities, but the classified nature of the information that could be derived by that would be beyond that which the countries owning the reactors would be prepared to put up with. They certainly haven't put up with it to date, and I don't think that the arrival of submarines in Australia with UK or US propulsion plants as part of them is going to change the position that the UK and the US have taken over decades of operating of these submarines. So in terms of understanding in the design of the reactor, I think that is a non-starter, and I wouldn't advise going through with it. The paper that was produced was on the 6th of July 2022, and if anyone has not seen it who is interested in this, I would welcome them having a read of it. At the moment, the discussions between AUKUS and the IAEA, as far as we can, outside observers like myself can gauge, have been going positively, and the Director General has twice, in May and June of this year, remarked at the Board of Governors meetings of the agency how confident and positive he's been about it. So I don't see this as being a significant problem. I think the proliferation concerns do not get magnified by Australia acquiring a sealed reactor out of the current production facilities that operate without proliferation concerns within the UK or the US. I don't see this as a significant addition to those concerns. And whilst of academic interest on the ability of spent fuel to be cobbled together into a nuclear explosive device, the fact that the Australian reactors will return to the cycles of the UK and the US do not increase the risks of proliferation. I'll end there. I'm welcome to lots of questions. I could talk for hours on how interesting it is to operate nuclear submarines and some of the challenges, but rather than waste everyone's time on that, I think it's probably more interesting to respond to questions.
Well, thank you for that, John. That was very useful. So we're not, I think in the discussions in the academic community, we're not casting any aspersions on either Brazil or Argentina. It's more trying to defend the integrity of the system, because if this technology moves on to other countries, we want to have a system that is universally applicable. That is how IAEA safeguards work, particularly in non-nuclear weapon states where they're non-discriminatory. Depending on the technology, the verification objectives are the same. So that's the broader concern. And while we trust the three AUKUS countries to say that they will follow the highest non-proliferation standards, we don't know what these are. But that's not our discussion here at this point. So I don't know whether you can comment on the following question. Even though the British and the US submarines apparently have a lifetime core, what would be the provision were there to be a fuel failure or some sort of accident in the reactor where the nuclear engineer needs to access the reactor? Are there hatches on the submarine at the top which can be opened so you can access the reactor? I understand that more hatches means more noise for the submarine, and submarine operators want fewer. Anyway, so were there to be an incident involving a radiation issue on the reactor, how would the nuclear engineer or the radiation specialist, either on board or on shore with the submarine on shore, be able to access the reactor?
I'm sure this question is slightly prompted by the K-19 Widowmaker film, in which the Soviet era sailors very valiantly get very close and proximate to the core of the K-19, which was suffering a significant and devastating malfunction. Modern reactors are not like that. The fuel is embedded within fuel plates, which don't look terribly much like the model, and the previous presenter was very clear that this was a simplified model in order to run the Monte Carlo. You simply can't go in and take the fuel out. They're embedded within other metals and other means of holding the fuel in the right place in the core. And you can't simply, by opening a hatch in the reactor, even if you were stupid enough to do that, given the radiation risk, you couldn't access those fuels by doing that. If there was such a significant problem with the core, then the core would be shut down, either in a normal manner or in an emergency manner, and it would be rendered useless at that point if it was an emergency manner, and the vessel would need to return for essentially a removal and refuel. That is a catastrophic failure, which outside of the former Soviet Union has never happened, or indeed come close. So that there is not a proliferation path with an access to the core fuel, even if you could take the rods out, which, as I say, and as the good doctor said earlier, once you've started using the reactor, these are not safe things to come anywhere near as a human being. But even if you get in there, you still would need a significant reprocessing or manufacturing facility to turn what is a fuel rod into its constituents. So I'm not sure of the point of the question, but you wouldn't have such a hatch. You wouldn't use it if you did have it, and you couldn't get the fuel out even if you did have it.
Yes, my question was more from a safety point of view, because fuel failures have happened in reactors, on land-based reactors. And then you have to go fish out the damaged fuel rods, which is easier in a normal reactor on land. So while we don't know whether there have been fuel failures in naval propulsion, so my comment was more from that point of view, not that somebody would open a hatch and fish out some rods, but from a safety perspective, if there's a fuel element failure, as the way we understand it, the reactor would need to be shut down and probably taken out and replaced. So it was coming from that aspect rather than from where safeguards aspect.
Well, one of the reasons why the countries that were operating nuclear submarines sought the exemption in the treaty for naval nuclear propulsion programs, being a non-proscribed activity, but still operating fissile material, to be excluded from the safeguards, is that in order to produce a design that is as immune to such failures that perhaps less sophisticated designs are sure in reactors where you have far more frequent and the ability to go in and be, you could take this rod and this rod out, shut the thing down, take a couple of rods out that have failed, put a couple of rods in, or are more susceptible as a result of that because their design is not so hardwired. Because the design is specifically, well, we need this for 30 years and we don't want this problem. It was about both the security but the proprietary nature of that design, and it's one of the reasons why these reactors are not cheap to design and manufacture. So I can't speak outside of the former Soviet Union, which has a particularly poor record with its seaborne reactors. But in my knowledge of both the US and UK naval nuclear propulsion programs, we have not come close to the sort of situation that you have mentioned by design. And in fact, the chances have reduced with each iteration of the design. And that is what moved, one of the reasons why the designs moved from midlife refuel to whole life design was to yet again minimize the need to interact with the reactor during its life.
Well, the proponents of this exemption were Italy, Netherlands, and Germany at the time in the early 70s when the Safeguards Agreement 153 was being negotiated. So we talked here about AUKUS, but for Brazil, it's an indigenously developed reactor, and they will make their own fuel, and they will use a low enriched uranium, as they say, as do the French. So this means that these submarines would probably need to be refueled 2 or 3 times during their service life. So would such submarines require a refueling hatch and stuff like that?
Well, I mean, the refueling of a nuclear reactor in a submarine is a significant event. I mean, I have been the submarine which I commanded had just completed a midlife refuel when I took command in the dockyard, and it's not a case of a hatch. You cut a hole in the submarine in order to gain the access. You remove the fuel cells and or the reactor depending on the design, and you replace them again depending on the design. This is not a hatch issue. This is a major garage-based refit that takes a number of years. But I mean, the principle is the same. You make a big enough hole in the submarine, you wouldn't want to then go to sea with a hatch that was as big as you needed to do that for a whole host of reasons. You simply weld a new top, if you like, into the submarine once you've completed the refuel. But the LEU designs, whilst having some benefits in both cost and initial cost, and indeed in running LEU, which is itself less of an issue when you're looking at nuclear explosive devices, do not have the power density of the HEU cores, and therefore, depending on how long you plan to operate the submarine, you are likely, as the French have found, to require 2 or maybe even 3 refuels during the life of a well-designed hull.
So for the participants, we'd like to remind you, please put your questions in the Q&A. We will not be going live to any participant for their comment or question. So there's one addressed to you, John, and this is sort of deriving from my earlier comment about the universality of the system. And so while we may be sanguine about Australia and maybe even Brazil, what happens when we have other countries? Iran has said its enrichment program, it can also be justified for naval propulsion, and there might be others, South Korea, Japan, Taiwan, and both South Korea and Taiwan in the past have had undeclared nuclear activities. So that's why the focus is on coming up with a system that's universally applicable and for the agency to have as much information as possible. And even though Australia may not have enrichment today, they do own and have developed SILEX laser enrichment. And this is a very long program over 40, 50, 60 years. So political views can change or requirements can change. So again, this is not casting any aspersions, but the comment is from a non-proliferation and trust but verify point of view. What leeway would a Navy have in giving the IAEA assurance that the chances of any misuse of nuclear material are minimum, if not non-existent?
I think it does present challenges if you look outside of the AUKUS bubble. The AUKUS bubble is unique in some ways in that the providing nations are nuclear weapon states with a nuclear propulsion and nuclear weapon industry and capability that preceded everything in treaty terms, whether it be the Non-Proliferation Treaty, all of the safeguard protocols and the IAEA concept that came after the UK and the US had these systems, and they are saying essentially the central part of their position is that the Australia will maintain itself as it is now, and they will produce into and out of an Australian almost nuclear bubble, if you like, and therefore that presents an almost unique situation. It is hard to see how you could as simply do that with countries that were either not operating with a former pre-NPT state or who were doing their own stuff. Nor, however, do I think that the AUKUS presents a precedent that increases the risk of any others doing it. They're either going to do it or not do it. And the unique nature of the AUKUS bubble, I don't think spins or precipitates that in either way, because any risk of South Korea or other countries indigenously producing their own nuclear power propulsion systems, or indeed any country that goes down the route of merchant marine nuclear propulsion in the future, will be doing so from a very different position, and they would do it independent of where AUKUS is going. So I think the view that AUKUS is, if you like, carving a new danger area, I think is misplaced because of its unique position. I do agree, although I have not studied it in any detail, so I wouldn't venture an opinion. I do agree that perhaps the Brazilian model, where although they have an agreement with France to assist them technologically and with advice, although I don't know the range or depth of that, is doing this as an indigenous program, is perhaps the one more to focus on in terms of the precedents that it sets.
Thank you. So we do have one example where the Soviet Union leased a Charlie-class nuclear-powered submarine to India, and now currently they've leased an Akula-class submarine. And one of the captains or commanders of one of these leased submarines, the Indian commander, wrote a book in which he mentioned that the Indian Navy had full access to all of the reactor and its design information. And apparently the reactor for the Arihant and other nuclear platforms for the Indian Navy have got information from the Soviet design. We don't know, but that's what he claims. And so India is not a party to the NPT and therefore wouldn't have the same obligations as the UK and the US if they wanted to transfer this technology to an NPT, a non-nuclear weapon state. This is a question more for UNIT. And a related question, UNIT, is would the agency be looking at some sort of a subsidiary arrangement under the respective safeguards agreements of a state wanting to have non-application of safeguards?
So regarding the NPT, of course, Article 3.2 does not prohibit the transfer of special fissionable material, right? So that can be done by nuclear weapon states parties or non-nuclear weapon states parties. But once the material arrives in the importing state, they have to inform the agency when they are taking responsibility, and this is based on the contractual arrangements. Of course, there are many technical details, but this is a general discussion. Whether subsidiary arrangements would be needed or not. So they are specifically required by the safeguards agreement to specify the details, yes, of the procedures to be applied. And actually, if you remember, so in Code 10, yes, we have the reporting formats for inventory change reports, physical inventory listing, material balance reports. And actually, we have the codes that the country can use for removing nuclear material from the inventory for the use for naval propulsion and bringing the material back after its use for naval propulsion. So the measures that could be included in the arrangements provided for in Article 14 might not be necessary as those that are included in the subsidiary arrangement general part or facility attachment. Yes. So if we look to the requirement, yes, for subsidiary arrangements and the evolving practice, yes, you see the agreement doesn't say the subsidiary arrangement should have 10 codes or 5 codes, yes, and the facility attachment should have a limited number of provisions, yes. That has evolved, and that is based on our practice. To maintain a solid and credible safeguards regime, yes, of course, we have to identify in consultation with the state the best measures that could be applied in order to meet that objective.
Thank you. So whatever arrangement is reached, would these arrangements with AUKUS and Brazil need to be approved by the board or just informed to the board, or they remain between the states concerned and the agency?
So Article 14 does not require that the arrangements to be made should be submitted to the board. There is no requirement in the CSA. If we look to the negotiating history of that paragraph, we can see that the very first proposal of a draft agreement that was prepared by the Secretariat did envisage that the arrangements under Article 14 be approved by the board. However, that was amended by member states who participated in the negotiation process. So the next version of that paragraph provided for the arrangements to be made between the DG, the Director General, and the state concerned, and there was no board approval required. In the last version, which was approved by the board, one delegation requested to replace the Director General with agency. So the negotiators of that paragraph and 153 as a whole did not envisage at that time, yes, a board approval for the arrangements to be made under Article 14. But as you can see, the Director General kept the board informed on all developments and the technical discussions that took place between the agency and the states concerned.
Yeah, so the DGs.
The board has, as you know, the board has specific functions under the CSA, in particular Article 18 and 19. Yes, so in cases the IAEA would not be able to verify that there is no diversion of nuclear material required to be safeguarded. So the DG may report to the board, and then the board may take actions as set out in Article 18 and 19.
Okay. So before reverting back to Sophie, one other question here is, this 153 is now 50 years old. It was agreed in 1972. Since then, the agency has gone through many iterations of strengthening safeguards. And you were there when we, Secretariat, proposed to rescind or amend the small quantities protocol in 2005. There were 93 plus 2 strengthening measures after Iraq. We have the additional protocol. We have the voluntary reporting scheme on americium and neptunium. So here, why are we sticking to Moses' tablet that because Article 4, paragraph 14 said this in 1972, we cannot reinterpret it, we cannot change it, we cannot do anything more. And last week, Safeguard Symposium was talking about all these new challenges, the state level approach, the state level concept. So why do we have these two contradictions, so to speak? Why cannot the agency and member states say, well, maybe we need to revisit the paragraph 14, and maybe given today's challenges, regardless of which country is asking for it, we need to revisit it and find new ways of dealing with this, whether to give this or not to give this, or to have more reporting or consultations with member states, et cetera, et cetera.
Of course, this is probably the only provision in the CSA that has never been used or tested. Yes, so we don't know yet. Yes, before making any arrangement, is this provision is good enough or not? But the arrangements that the agency and the state are required to do, yes, are not, let's say, limited to one element only. So if the state wants to have a strong arrangement and strengthen the credibility of safeguards and our verification mission, so we can include all necessary elements that would enable the agency to achieve that goal. So going back to the history, yes, early 90s when the safeguards under the CSA were strengthened, so everything started with the special inspection, right? So we have a right under the CSA to perform special inspection, yes? But because of the context of the discussions in the board, yes, that tool, which is available and is a right, has not been used in a routine manner. There were other issues where the board was involved, like the provision of design information for a newly built facility. So we had a 20 years practice, and the state that was constructing a new facility provided design information only 6 months after, before it introduced nuclear material. That made the possibility for the agency to develop a sound safeguards approach very difficult. That was modified. In the context of 14, we have no experience. So that's why the consultation process and the technical meetings with the states concerned are essential in order to develop a good and strong arrangement under Article 14. So if that will happen, the future will demonstrate.
Mm-hmm. Yeah, so this was one of the comments that was made quite often last week at the Safeguard Symposium, that the Secretariat should not spring any surprises and there should be good communications. And that's why in my writings, I've been arguing that just for the SQPs and for the project I worked on, fuel assurances, we did a lot of consultations with member states before proceeding. Moving to you, Sophie, do you have any comments to what Admiral Gower said with regard to the submarine reactor and related matters?
Yeah, I enjoyed listening to you very much, John. And I have to agree with you also that we are in the bubble in the AUKUS deal, but I am to some degree concerned that it sets a precedent that other states may follow, and as you pointed out, Tariq, there needs to be a universal solution of how to handle the situation with various types of fuel in submarines operated by a number of states. I'm sure it will be a considerable challenge ahead. And I also noted there was a question in the chat window related to the deployment of SMRs. And yes, I think that if we consider SMRs to be a challenge for the non-proliferation regime, in my opinion, not representing the IAEA, but it seems like having them in submarines is even more of a challenge. But on the other hand, not under safeguards, since they are a military application. So it is a tricky situation indeed, and I'm wondering what will come after this, if the operation of nuclear-powered submarines will actually lead to motivation to actually start up additional fuel cycle activities in a state, despite this is clearly not the case at this stage, but who knows what will be the case in the future.
Yes, that's a good point. So you responded to the comment about small and medium reactors, SMRs, and the proponents of SMRs say we have more than half a century of experience of SMRs, small medium reactors of under 300, I think, megawatts or kilowatts of power in nuclear submarines and then surface ships. So the technology is proven. The only difference is that in naval use, they are outside any international monitoring or verification. There was also a question about the bubble. So the bubble that Admiral Gower talked about was in the case of AUKUS for a country which is a non-nuclear weapon state party to the NPT. India is not a party to the NPT and therefore is not part of any bubble. And as UNIT explained, any exports of naval nuclear propulsion technology by India to a non-nuclear weapon state party to the NPT would need to be reported to the IAEA, and that state then would also need to trigger the paragraph 14 non-application of safeguards. So we're close to ending. Do three of you have any points or comments to each other?
I just wanted to re-emphasize that the use of the word bubble was something I shorthandedly made up there. It's not something that people are using. It was just a descriptive tool. And whilst the SMR, whilst the companies that are pushing SMR may say that we collectively have all this experience from naval nuclear reactors, actually they don't. And I think it is a fake translation from one to the other. The vast majority of merchant marine shipping lines and captains are very competent, but there is also a very significant number of merchant marine shipping lines under flags of convenience and captains of dubious skill who are not quite so competent. And so I don't agree with Sophie's characterization that the bigger problem rests with submarine-based reactors. I think the bigger problem will rest with SMRs when and if they come in, because the accident rate is likely to be higher, and the control of the propulsion systems is not in a national security environment. It can't be if it's going to be in Maersk and other big shipping lines. So I do think that I do agree with you that a metric needs to be constructed, but I don't think the biggest problem is with submarine procurement programs like AUKUS.
But I think there's still an issue with submarine operations. As you know, a British and a French submarine, I think missile submarines collided off the coast of Gibraltar some years ago.
Not off Gibraltar, but yes.
Okay, wherever it was. At least one or more US submarines have surfaced under a fishing trawler or whatever and are bumped. The upholders that Canada got from the Royal Navy, they said there were dents on 2 of them, even though these are conventional submarines. So when you said that the experience of naval SMRs, if we use that term for the civilian, is not relevant, but if we have these newcomer countries operating nuclear-powered submarines, and as you said last year, it's very different to operate a nuclear submarine compared to a conventional submarine, don't we have then risks of operator issues for newcomer states to naval nuclear propulsion?
Yes, but all of the collision issues that you've raised did not come close to being a reactor problem. The USS San Francisco ran at 33 knots into a rock in the Indian Ocean and did not suffer a reactor problem. So I don't characterize the fact that there are collisions because these reactors are designed to operate under war conditions when the vessel in which the reactors are carried are under attack, and they're designed to operate even when that vessel has been struck by weapons. My comment about the civilian SMRs, should they come forward, is they're unlikely to be designed and constructed to the same rigorous needs, because you don't expect them to suffer that. And the cost would become astronomical, and therefore Maersk would not go down that route. So I think it is perfectly legitimate to say that the risk of accidental damage to a reactor in a civilian ship is higher than it is to a military vessel, and the only military vessels currently operating reactors are submarines.
Also not aircraft carriers?
I'm sorry, I didn't hear that.
Aircraft carriers?
I beg your pardon. Yes, also aircraft carriers, but again, designed to the same initially exactly the same reactor as the US had in its submarines. Clearly not quite so constrained by size.
Right. Do you have any concluding comments, John? And then we'll go around with the others.
No, I think I've said it all.
Okay, Sophie.
I fully agree with what you said, John. I was also considering small modular reactors, not only at sea, but also at land. But yes.
Okay, and then finally, Unit, over to you. We didn't talk about transportable reactors, which may be acquired by non-nuclear weapon states, and probably those would need to be under safeguards as they are not military reactors. But still, there might be some points in common in terms of technical objectives for safeguards and legal considerations. So the final word over to you, Unit.
Thank you very much. Actually, we did a study, a tech doc, which was published in 2012 regarding the safety, security, and safeguards implications for transportable reactors. And of course, subsequent scenarios have been discussed, whether the reactor will be produced by a nuclear weapon state and deployed in a non-nuclear weapon state, or produced in a non-nuclear weapon state and also used in a non-nuclear weapon state. So these are scenarios. But of course, we have to work with the industry. We have to understand, and promote safeguards by design. which are important in ensuring the safeguardability of new technologies. So we have meetings, we published technical documents. We are also working with member states through the member state support program to develop safeguards approaches for transportable reactors. Of course, that will be based on design information that will be provided by those that have experience in such technologies. Regarding going back to naval propulsion, so we started 60 years ago with small research reactors, yes? And after so many years, the agency safeguarded successfully all type of facilities, big reactors, conversion plants, enrichment plants, fuel fabrication plants. So I'm sure member states and the agency would be able to find a good solution to implement Article 14 and maintain the safeguards effective.
Thank you. So we've had a good, interesting discussion today. As you can see, this is a big subject. We've touched upon some issues. There are several other issues that we could have discussed. So I would like this opportunity to thank Admiral Gower, Dr. Sophie Groppe, and my former colleague, Unit Susanu at the IAEA, and also to the participants and to those who sent in questions and comments. And I hand back over to Benedikt Zanzinger at the Konrad-Adenauer System.
Well, thank you very much, Tariq. I would like to thank Sophie for your presentation, Unit Susanu for the legal insights, and Rear Admiral General John Gower for particular insights into challenging present and future of nuclear submarines and nuclear naval propulsion in general. Thank you, Tariq, for this excellent moderation and your expertise on this field. It's always a pleasure. You've all shared with us important overview of a very complex picture with key background information and a lot of food for thought, which definitely should be elaborated further on. I also would like our audience from around the world for your comments. I think we've seen how important it is to provide a platform for dialogue worldwide, and the Konrad-Adenauer-Foundation will keep on providing those platforms, either online or in person, to discuss topics related to nuclear arms control, disarmament, and non-proliferation. Please make sure to follow the website of Atomic Reporters and the Multilateral Dialogue for further information. And also check the website for the upcoming webinar, which will be held soon. Please check the YouTube channel for the recent videos on the webinar series, and do not forget to watch the video mentioned in the beginning, Nuclear Submarines, Who Will Get Them Next, for those who joined us later. Now, I wish you all a pleasant rest of the day. Thanks for being with us. Stay safe and hope to see you soon on the webinar. Goodbye.
Thank you all. Thank you very much for joining us today. Bye.
Bye. Good night.
Thank you.